Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to all of you. Okay, guys. So this is week 3, right? Week 4. 3 or 4?
4.
4. Allah. Time running very fast, you know. So we are in
Doctor.
4, week 4. Okay. Thank you for remind me for trip 4 already, week 4 already. Okay, we should finish on this chapter 3 as fast as possible, because I want to move on to we are trying to move forward to, we call it chapter 4, which is energy audit, for you as the guideline for you to do the PBL, problem-based learning in a group assignment. All right. So perhaps for the next weeks, I try to get large room, a large lecture room for us to do the face-to-face teaching. So face-to-face class, so that you can come to class and we can do some discussion as well to as the summary for chapter 1 and chapter 3. So for your information, another part will be the midterm exam, midterm test, okay, that we will have on before midterm break. So that one is the face-to-face. I think what I mean is the physical examination, okay? So there's no more online for the midterm test, so you will you need to come and answer the question in as the physical okay condition during the midterm test later on. So please be in mind that you need to come to Malacca as well as to come to the campus. Ada lagi yang kat rumah tak datang ke Melaka? So please ensure that you need to come to campus, okay? So you are currently in the last semester, so that you, university consider you to get ready to be a graduate later on, okay? To enter the job market, you are bringing the names of UTM as the graduate from UTM. So you know that's a not simplify. You can get the certificate without you sit down and answer the test. So we need to have some sort of the assessment before you can get graduation, especially for this subject, because we have another additional certification, which is the professional certification, that you are eligible to register as energy manager later on under Suruhanjaya Tenaga. So that's why for this subject, among lecturers, we are deciding to, we have decided to do the face-to-face class later on, maybe the selected topic, because my class, for my class, quite surprised with the numbers of students that, and also we are receiving the student from the other section as well. So we have currently about near to 80 students in the class. So that one is the constraint to get a large class for me to deliver the lecture. Okay, because the you know, the COP, etc. So we need to follow the SOP, the distance, for example, in the class. I hope you can understand, and I try to get face-to-face class later on for next week, the chapter 4, which is the energy audit. Okay, so I will try, inshallah. So can we continue? Are you ready, class? If you are ready, please put something on the chat box. Are you ready? Write something, guys. All right. Thank you for your response. Good. Okay. Thank you. Thank you. All right. So today we are going to continue on the tariff based on demand. So we know that tariff, the base, the main component of the tariff. Okay. So we have what? The main component? We have key. Asal jadi pensel pula. Ya. So we have kilowatt hour, the main component for the electricity bill, okay, which is energy consumption kilowatt hour plus maximum demand in kilowatt. This one is the maximum demand. So today we are going to discuss about the demand. So the monthly cost of electricity supply to large consumer. We consider kilowatt hour charge multiply with some value for the RM, for example, 30 ringgit per kilowatt hour. Okay, so you have calculated the rate for C1 yesterday, right? So the examples and also the example for C2. So you understand what's the component of the C1. They have a flat tariff, which is only to consider MD and the kilowatt hour in flat, total kilowatt hour multiply with the flat tariff, which is the flat price. But for C2, okay, the components, yeah, we can consider three components lah, three components, which is the peak price, the peak kilowatt hour, multiply with the rate in RM and plus off peak, multiply with the rate for off peak and plus MD charge, multiply in kilowatt, okay, multiply with RM, the rate for the MD. So this one is the total cost, electricity cost, the main component. All right. So this one is examples of the half hourly load profile pattern. So please be in mind that this one is the 24 hours profile. Like yesterday, you was introduced by a load profile pattern from the hospital. So today the same pattern. Look at the pattern, something like here. Okay, so we are trying to find the peak demand over here. So it must be kind like within this time period. Okay, between this one from 1:30 to close to 4:30 5. So this one is the peak area, and also it can be a maximum demand reading if that this area within 30 minutes, okay, have a large power, consume a large power in kilowatt. So the demand charge will be imposed to the consumer, okay, based on the uh, consideration of the 30 minutes, 30 minutes. Remember, 30 minutes. So 30 minutes of large power during the large power, 30 minutes. So every single 30 minutes here will be counted by a meter, which is the maximum demand meter. Okay, for example, here and here 30 minutes. The 30-minute time interval, okay, for the peak and the large 30 minutes will be considered as the maximum demand. So demand charge and excellent incentive to do the load leveling or load called peak shaving will be imposed to, will be one of the price signal for the utility to the consumer. So utility will offer some kind of the demand incentive if the consumer can reduce the maximum demand. So the strategy so-called peak shaving is introduced by many kind of the practitioner in the industry, and also you can find throughout the papers or journals, research journal around the world. So they use peak shaving and also for peak clipping, okay, peak clipping to mitigate the power, the maximum demand value, the maximum value. For example, here we have some kind of something like this, 24 hours, okay. So this one is the area for peak. So on how to reduce this peak demand, many kind of the initiative that you can do. For example, during the lunch hour, if this area is within the lunch hour, so you can put a strategy to reduce the maximum demand during this lunch hour. Okay, for example, to do the camping for shutdown before you leave. People inside the building can do the practice, something like shut down their computer or put it in sleep mode when they are go to get their lunch, to buy a meal, so they can put their computer in a sleep mode or shut down the switching, the lighting, okay, the plug load, etc. So that from that way, okay, so this kind of a building will be able to do kind of the peak clipping or peak shaving to reduce the maximum demand cost. Okay, let's see the examples of the two factories, A and B, are presumptively connected to a high voltage line by transformer A and transformer B. Okay, factory A and factory B. This one is the what we call it, the power for the 1 month. 1 month, the power pattern for the 1 month, the load profile. Load profile, okay, for 1 month. So this one is for B. And we can see here the energy drawn by this factory A is approximately 700 720,000 kilowatt hour. Okay, this one, the maximum demand. The maximum demand is 1,000 kilowatt hour. Okay, you can see here the something like fluctuate for the kilowatt fluctuate. But this one, why the consideration of the maximum demand is only 1,000? Because of the definition of the maximum demand, the load within 30 minutes, the power draw, the large power draw within 30 minutes. So we can see here, it's much fluctuate that not achieve, or not, the period is not 30 minutes, not 30 minutes, but this kind of the pattern, perhaps it fluctuates for within less than 30 minutes. For example, 5 seconds or 5 minutes, that one is cannot be considered as maximum demand. But for this factory A, okay, so I think they are very smart to start up the motor, for example, to have a strategy for the motor to start up and running their operation, so that they can manage to have only 1,000 kilowatt. But okay, nevertheless, for the factory B, we can see here factory B okay, use the same value of the energy consumption. But however, for the maximum demand, it is higher when it is compared to factory A. Because, okay, so maximum demand here, maybe this pattern, okay, is taken when the power draw is within or more than 30 minutes here. Okay, that's why the consideration of the maximum demand is 3,000 kilowatt. Any question? Any question? If you have no question and I have one question for you, okay? So which one running 24 hours? Which factory running 24 hours? A lot of things that we can get the information from the load pattern, you know. Even when you have the 24 hours load pattern, you know what's the activity that they have done, and they have should not to done due to wasted of the energy. So which factories that run in 24 hours? Anyone can answer me? Daniel, okay, good. Nabil, Shafiq, factory A. Why? Why? When you answer A and it is some kind of, you need to provide your reasons as well, right? So why? Okay, good. Okay. So as mentioned by Shafiq, okay, so we know that this pattern, all the days, so they're running for 1 month with 1,000 kilowatt, 1,000 kilowatt here as the power, and we know that this pattern is kind of 24 hours running, continuous running. So we know factory A is the production based on 24 hours production, and factory B, okay. So got here, we got to know that it is must be weekend because they do not have any pattern of energy consumption for this period. So we can consider this one is weekend. We can. So we have in 1 month 30 days, okay, two days, and we got 8 days for the weekend. And we know that factory B do not run their operation during this weekend. So the types of the manufacturing was different, and the running hours also different, okay. And of course the product output, I think, difference among them. And but we know that running 24 hours doesn't mean that your consumption or your bill of electricity is higher when compared to the some place that have their that stop their operation during weekend, okay. So by this way, so how to this one is the how they get the kilowatt hour factory A, okay. So let's calculate the tariff for factory A. So by using E1, let's consider that factory A use the E1 tariff. So what's the electricity cost for factory A? So let's refer to the yesterday. I did mention about the many type of tariffs. So you can refer to E1. So E1, what's the price for the maximum demand? Berapa? RM berapa ni? Rujuk cepat. Please refer. Please help me to refer the notes or TMB website. Perhaps you can refer to TMB website as well to get the E1, okay, price for MD and also for energy consumption. Berapa? 2960 maximum demand. Energy consumption, kilowatt hour. This one, kilowatt. 3370 sen. So please do not make silly mistake during the examination. So when I put in sen, please convert to RM. Okay, when you calculate the energy consumption and you simply multiply with 3.70 sen, and you can get different value after that. Okay, so please convert to RM. Be careful, be careful. So 0.0337. Okay, now please calculate the total bill. Total bill. Berapa ni? RM berapa? Dapat. Yang ni multiply with 0.337 and the maximum demand 1000 kilowatt multiply with RM 29.6. Okay, get this both of the value and sum up, total up to be the total cost for this factory A. Berapa? RM 272,240, betul? Anyone? Okay, good, good. 240. Okay. So now we know that the value for the tariff E1 for factory A. So let's consider the tariff for factory B using E1 as well. Kira 72000 kilowatt hour multiply with RM 0.337. This one is for energy consumption, and for maximum demand 3000. Dia keluar pula. $3,000. Okay. Ada yang dah dapat dah? Factory B ni berapa? Yang ni multiply with 0.337. This one 39 point. Apa tadi? 0.6 eh? 39.60 RM. This one RM. So plus both of them can get the final RM berapa? 331440. 331440. This one is the total bill if they use E1 tariff. So we know that when the maximum demand is higher, and of course it is reflects to the maximum demand due to the higher energy cost, the total energy cost for a monthly electricity bill. So when factory B is compared to the factory A, and we know that factory B is consume the same energy but different amount of maximum demand, and the factory B factory B's electricity cost is higher compared to factory A. Okay. Ini kita dah buat ni. Okay, let's proceed to okay, let's proceed to this one. Okay. For any month shall be deemed, okay, this one is the maximum demand consideration. Consecutive 30 minutes. Okay, consecutive 30 minutes. So remember this terminology or the definition for the maximum demand. Okay, one, you can consider peak demand for the fluctuate one, okay, that less than 30 minutes, but the large number of the power used within the 30 minutes or consecutive 30 minutes, okay, that one we can consider as the maximum demand. Okay, maximum demand calculation for this one, E3, yeah, E3, that use E3, okay, the peak period. This one is the case, case example. Assume E3 consumer. Okay, this one is the January load profile, 1st January, okay, for 1 day. 1 day or 24 hours. Okay. So we assume that this value, the top value of the power demand here is 67,190 kilowatt. Is the highest MD for the month during the peak period. Peak period, peak period. Even though we found that the most highest power draw by these 24 hours or the by this manufacturing is 77,380 kilowatt, but this one we cannot consider it to be um, maximum demand. Okay, the maximum demand will be picked up from the peak area only or peak period only. Okay, so that's why for the manufacturing, they're able to manage their load pattern, so they will enjoy the maximum demand reduction as well as the cost reduction for the electricity bill. For example, for the operation, manufacturing operation, they're able to shift from the peak area, from the peak period, the operation, they shift to the off-peak period during after the 10 p.m. So they can able to reduce the cost of electricity and also cost for the operation, manufacturing operation. Okay, like for this example, so no charge for the peak demand during the off-peak because the peak started from 8 a.m. to the 10 p.m. here. So the maximum demand after the demand after the 10 p.m. to close to the 8 a.m. every day will not consider as the maximum demand. The maximum demand is considered within the peak area only. So remember this one. Do not do the very simple mistake, something like this. Try to understand what's the maximum demand. So what's the area that the power, the 30 minutes power has been taken? Okay, that only during the peak period. So maximum demand here is 67,000 kilowatt. Okay, so off peak, this one off peak, so through the different, okay. So how about for to June with a different year, okay, something like here. So look at the value here. So peak and off peak. So okay, the MD charge will be considered from the peak one to be here. So E3, if you use the E3, then multiply with 35 ringgit. So you got the maximum demand. Around 2 million. Wah, maximum demand saja dah 2 million. So plus to the energy consumption, and can you imagine, you know, the biggest of the operation for this manufacturing? And from my experience, I got to deal with the large manufacturing, some kind of from the solar panel producer. They use they consume the energy with the large number, and their bill, the electricity bill monthly, I think, if I'm not mistaken, close to 10 millions every month. 10 millions, you know, can you imagine the large number of operation costs to maintain the manufacturing? And of course, I believe that their profit also very large to cover their operation. Okay, demand control. So what we can do to control the demand, maybe you can have some kind of the idea on how to sustain the energy consumption by applying the energy efficiency appliance or solution. And also for the maximum demand, frequently in industry, they monitor the demand as well, to lower down the maximum demand, and to get, for the example, an alarm can be installed to sound a warning whenever the demand is about to exceed a pre-established maximum demand. From the building management system or bus system, building automation system, you can put some kind of the indicator to monitor the maximum demand. Okay, for example, something like controller, you can put the controller to prompt the alarm. Okay, when it is near to close to the set point of the maximum demand. For example, 10,000 kilowatt you set as the set point. Okay, so close to the 10, when the load or power you use to close to the 10,000 kilowatt, for example. So an alarm, to the sound of alarm will be prompt from that system. So the operator will know, okay, something wrong with the load right now, and must do something with the operation. So you can manage to to look around the operation, okay, and to have some idea what's kind of the machineries of the or the device that really need to be shut down during that time. So that's a good to monitor, and maybe you can have some idea later on, okay, to do a research, or to produce some another technology that easily control the maximum demand without without um, without disturb the operation. That one is really important to avoid the disturbing for the operation to produce the output, and to optimize the operation within the limitation of maximum demand. So you can do something to think and to provide the technology to the consumer. See, that one is another opportunity for you to do an innovative product or to establish your own business later on. Okay, any question before we proceed to the other subtopic, which is demand side management tariff initiative? So hopefully we have covered some topic which are really important that on how to calculate the tariff. At least you know the type of tariff and you know how to calculate the total bill from the energy profile, pattern, and also the consideration for the maximum demand. Any question before we proceed to this another topic in class? No question. Can we proceed? Okay, thank you for your response. All right, so what is maximum demand side management tariff initiative? Okay, so forgot about maximum demand. This one is not really means the maximum demand just now, but demand side management is the composition of the energy efficiency and the demand response, which is the program that provide to the consumer, for example, to reduce the electricity consumption and also to mitigate the peak demand and purposely to reduce the stress on the generation side. So usually the goal of the SM is to encourage the consumer to use less energy during the peak hours or to move the time of energy use to the off-peak hours night. Okay, this one we call it as load shifting. Load shifting. Okay, so I did mention about peak clipping and also for peak shaving. Okay, peak shaving, but this one is load shifting. Okay, so to shift the peak, to shift the operation during the peak period to the off-peak period. So you know the pattern of the electricity just now. Can you imagine that we have to kind of the zone for zone 1 is peak period and off-peak period. So to shift the operation from the peak period to off-peak period, because when the TMB introduced the TOU, time of use, okay, so they offer a better, lower price for off-peak, right? Off-peak period. So why not for the consumer, in order to enjoy the cost mitigation for the electricity, they try to shift the load from the peak area to the off-peak. Okay, the tariff initiative under the SM is usually called as demand response. So TOU for C2, E2, E3. So this one, and also for the off-peak tariff rider of PTR and ETOU, enhanced time of use, this one is under demand response program. So probably the TMB want the consumer to respond, okay, to respond with their tariff signal or price signal, so that consumer can do some strategy, we call it as load management, to shift their operation from the peak area to the off-peak. So for example here, is it not really clear? But for this time being, you can refer to your own slide. Okay, if this one is not so too clear, but for this peak demand at 7 p.m. So demand huge between this 5 to 9:30 p.m. from here to here. Okay, the peak demand happen or occur during the 7:30 p.m. So demand minimum during the morning here, 12 a.m. to 6 a.m. here. But on how to get this one, okay, the load curve for this manufacturing, for example, if they want to reduce the cost of electricity, okay, they need to shift their at least the operation here to the off peak, maybe during after 10, okay, to bring to will be something like the pattern will shift to the after 10 p.m. Okay, so at that for this condition, the manufacturing will reduce the electricity cost simultaneously. So I did mention about demand response. Okay, we got two kind of different tariff for demand response. So therefore, consumer to have a very important role to play for achieving the objective of the DSM. Because without consumer, so no point for the demand response program or for the demand side management. Okay, so the price signal from the utility, from the TMB, for example, should be used, okay, by the consumer to respond back to the price that offered by the utility. So by that way, we can see a large number of the peak generation, peak during the critical hours, can be shifted to the not critical hours, something like off peak. So that's why the MB offer the different kind of the tariff for the consumer, for the commercial consumer, for the industrial consumer. So because they are use or consume the large energy from the generation, about, okay, I think about 75% of the energy that has been used by consumed by this commercial and industry in Malaysia. So benefit of demand response, customer benefit, justify electricity demand, reduce the cost, maintain improved lifestyle and productivity. Okay, so without lower down the lifestyle and productivity, they can maintain, but properly manage their what we call it, their operation. So utility benefit, lower cost of service. Okay, during the critical peak hour, they can reduce the service for the peak hour and also improve the operating efficiency, flexibility on the load management, improve customer service. Yeah. So for the social benefit, of course, this one is the ultimate goal for the demand response to reduce the environmental degradation. Okay, so the energy consumption reduction, from the first chapter, I did mention about the CO2 emission and greenhouse gas. Okay, so we are trying to achieve ultimate goal to reduce the energy, the CO2 emission to the environment. So we know that that one is our responsibility as a humankind to do the best for the environment so that we can transfer a good environment to our next generation, and we do not be blamed by them that we have done our part. So please do the best for your period to maintain or to sustain the environment. So that's why with our practice nowadays, we can transfer a good practice, a good environment, a good lifestyle for the next generation, and they can also can have the idea what we have done before and continue a good practice to protect the environment. Okay, agree? Tak ada orang nak respon pun. Faham ke tak ni?
Agree, Doktor.
Okay, to reach the conservation of the resources and protect global environment. So today, I read from the Reuters, one of the famous news. Today is kind of US. We revised the tariff for the solar panel import from ASEAN countries like Malaysia, Vietnam, Thailand. They noticed that some biggest company from China has established large manufacturing in ASEAN. So they from these countries, we also supply the panels to the US and have a special price because we are from the poor or developing country. So they import the solar panel with the more cheaper price compared to the US producer, solar panel producer from internal from US. So they have issued some problem with this kind of the process. Okay, because Joe Biden, the US president, has announced by 2035, okay, 35 or 30, they want to achieve zero fossil fuels of the generation. Can you imagine US as the big countries, and as the leader for the most of the countries in the world? so has announced that a policy to get zero fossil fuel generation, and that's one is the good news for the RE to drastically um, improve that numbers of the generation from the RE. So most of the economy was, I think, will be established based on this policy later on, and yeah, to be a competitor, so you need to have a better technology and a better price. And the Reuters also reported that 80% of the solar panels nowadays in US was come from ASEAN countries, and we are one of the largest exporter to the US from many manufacturing here. And I think because of the manpower cost, etc. Okay, so the provider from US cannot compete to the China's product and also from the ASEAN country products of solar panels. So we can produce a solar panel with a cheaper price and can export to US as well. Okay, so about 80% solar panel that has been installed in US came from China and also from the ASEAN countries. So that the tariff or the tax will be revised from the US government. So let us see how this problem will be solved by the agreement, US and China agreement, and also from the ASEAN to the US agreement. All right. Banyak pula. Okay, type of DR, this one SIT. SIT dah tak ada. Okay, so do not focus on SIT, but we have OPTR and standard tariff, special industrial tariff, SIT dah tak ada. Okay, so for the previous one, SIT was introduced to the large power consumer, so they can the process to apply for the SIT, you need to have a good practice for the energy management to provide energy policy, to appoint the energy manager, and to get the objective for the energy management. Okay, so there were several types of the operation that can apply for SIT, and they can have a discount for up to 5% every month for the electricity. So that one, this SIT program was stopped by the government for the last 5 years lah. Okay, industrial consumer, also we have OPTR, okay, so OPTR and also STR, Sunday Tariff Rider. Now, this one OPTR. So OPTR offer to OPTR, off-peak tariff rider that offer to the MV medium voltage, C1, E1. So this one are not available. That TMB offer, you can enjoy 20% discount on the electricity usage during the off-peak hours from 10 p.m. to 8 a.m. every day if you can able to improve with the okay, the point of TMB offer this PTR, okay, you need to improve the load factor, the load factor. So you are eligible to enroll in the OPTR if you are from the TMB consumer C1, E1, and you have been receiving electricity supply for at least 1 month, okay, and your latest load factor is higher than average load factor over 6 months prior to the application. Okay, so let's say you are C1 consumer, okay, you want to apply for the OPTR scheme. So TMB will monitor your 6 month average, 6 months average of the load factor. For example, January to June. Okay, so TMB will provide the average load factor of, let's see, the examples, load factor is 0 to 1, 0 to 1. So 3.35, 0.35, the average load factor. So this one will be the baseline of the load factor. So in order to enjoy the 20% discount, okay, you need to improve your load factor. For example, this one is the load factor given by TMB, the average load factor, and you need to improve this load factor every single days or for that month, okay, and you can get the 20% discount for the off peak during 10 to 8 a.m., 10 p.m. to 8 p.m. So what's the value? The value of the load factor must be more than 0.35. So that's mean you need to have a good consideration for the maximum demand and the energy consumption. So what's the load factor? What's mean by the consideration of load factor? Load factor is, this one is the formula for load factor. Nanti tolong salin ni. Energy consumption over maximum demand multiply with hours. This one consider 24 hours and multiply with the days in 1 month, in a month. So let's example, that month is 30 days. Okay, you can put 30 days. Nampak tak? Tak clear? Sekali lagi ya. So I repeat the load factor, energy consumption, kilowatt hour for, if you want to get the load factor for 1 month, okay, consider kilowatt hour in 1 month. Okay. Over the value of maximum demand. Okay, you know the value of the maximum demand. I did mention about the maximum demand for the from the previous slide. Okay, multiply with the hours. 24 hours. Okay, multiply with the days in a month. Kalau 30 lah. Kalau 28 Februari 28, consider 28. Okay. So this one is the load factor. So on how to improve the load factor, you can see here. Okay, you can also maintain the energy consumption, but you need to lower down the value of the maximum demand, right? So suddenly you can improve the load factor. or you have something to install to reduce the energy consumption. So your energy consumption reduce, and also you need to reduce the maximum demand as well. Okay, to balance the consumption and the maximum demand, and of course you can improve the load factor. So to enjoy the OPTR program, you need to improve the load factor. So every month, TMB will provide you the load factor value from from the baseline. If you're able to improve from 0.35 and above, and you can enjoy the 20% discount for the off-peak period. Any question? No question. Okay, you can proceed to STR. This one's very simple. So the consumer that subscribe this STR offer to all the industrials consumer, E1, E2, and E3. So this one no more special tariff for E1, E2, and E3. Okay, so customers will still pay the same rates on the electricity usage and as their current tariff. However, for the maximum demand charge are not applied to any electricity usage on Sundays. So this one, I think for the Johorian companies operate or manufacturing, and also from the Kelantan, Kedah, and Terengganu, they can enjoy this one because they are working in a Sunday, and they can put the maximum operation for the Sunday as well. If they want to have a lot of things to do, they can bring all those things to a Sunday, because for the STR, TMB will not consider maximum demand for the Sunday. It's one advantage for those state that working for Sunday. Working on Sunday. Okay, so any other question? We have OPTR. We have this one is the initiative, tariff initiative, and also TMB consider the reduction discount for the education institutes, and also for welfare house, and yeah, for the rumah ibadah, STR, okay, that one. And another initiative tariff from TMB, this one is new, but started in 2015, which is the OPTR. Okay, you can see here, instead of 2 period for the TOU, this one is TOU, okay, TOU, and for the ETOU scheme, TMB has put mid-peak here, mid-peak. We have peak, off-peak here, and also TMB have put mid-peak. We have 3 zones instead of 2 zones for TOU, okay, TOU, but for ETOU have 3 zones, but this one for TOU they have only 2 times segment, okay, this one 1 and 2. But for this ETOU, I think there are 6 time segment have been provided by TMB. 1, 2, 3, 4, 5, and 6. Okay, that's the arrangement of the off peak, mid peak, peak, mid peak again, and peak again, and mid peak again, and lastly they come out with the off peak. Okay, 6 time segments. So compare the comparison between TOU and ETOU. TOU and ETOU. So please read more. If you want to understand more about the TOU and ETOU, you can refer to TMB website. Okay. And frankly speaking, last year, this kind of the question has been asked in finals, examination, and also in midterm tests. So please try to understand what's the difference between time of use and enhanced time of use ETOU. Okay, so what I can say here, the time zones is different. So for the ETOU, instead of peak and off peak only for the TOU, but for ETOU, ETOU, they have put mid peak zone, as the additional to improve the TOU. And also, ETOU, they offer off-peak charge for Saturday, Sunday, and holiday. Instead of TOU, TOU consider all the days in a month with the same rate. But ETOU, TMB offer Saturday, Sunday, and public holiday for the off-peak. Okay, off-peak, and the maximum demand also will be not charged for the Saturday, Sunday, and public holiday. So for weekdays, TMB offer with 6 segment time. Okay, off peak, this one peak, and this one mid peak, peak, mid peak, peak, and lastly mid peak. 6 time segment with 3 zone. Okay, and this one is the time offer. Large power consumer, LPC billing, TMB definition. Okay, power factor. This one is one another part, but I think in year 2 you have learned about the power factor. What is the power factor? What is the power factor? So effectively, you know how to get the power factor. So what we can see here, to consider the power factor, okay, consider 2 factories X and Y. So power factor is one of the important additional or other component charged by TMB if the consumer cannot achieve the standard power factor. For example, 0.85, for large consumer 0.9. Okay, because the lower power factor will disturb the TMB system, especially for for transferring the power, the real power to the other consumer. So let's see this one. Consider 2 factories X and Y that consume the same amount of energy kilowatt hour and have the same maximum demand. However, power factor of X is unity while that of Y is 50% only. So very good. This one is unity. So X doesn't matter. So because power factor equal to 1, and this one equal to 0.5 power factor. So must be something and must do something for the power factor improvement, so that the manufacturing will not be charged by the utility. So apparent power draw, okay, 1000 kVAR ni, kVA, and for factory Y 1000 kVA. So because and factory the utility, okay, most utility per factor must be greater than 0.9. So how to improve? Okay, how to improve? Look at here. This usually done by installing capacitor. So to put the capacitive load instead of reactive load, okay, we know that when the power factor is lower, and we know that the reactive load is a major load. The type of load is from the reactive load, and we need to put the capacitor. So install the capacitor bank, for example, as the service entrance to the plant and on the load side of the metering equipment. This capacitor may supply part of all of reactive power required by a plant. Industrial capacitors for power factor correction are made in single phase or three phase unit rated from 5 kVAR to 200 kVAR. Okay, so you know the new one will be something like this because we have removed the reactive power. To put the capacitor, okay, this one is O maybe. To put the capacitor, something like can reduce the what we call it, the reactive load. So TMB impose all industry and large power to maintain the power factor to no more less than 0.85. Okay, so failure to achieve that numbers, so penalty will be imposed to the consumer. The penalty incorporate into a tariff structure and will be counted as the cost for the electricity bill. So let's calculate the penalty for the power factor. Nak rehat dulu ke? Take 5 lah, take 5. Can lah. Saya pun penat dah. Sejam setengah bercakap ni. Okay, take 5. 3:30 nanti kita mula. Okay, let's continue our class. Okay, at least it will take for about 20 minutes. Bye-bye. All right, TMB power factor surcharge. So there are two conditions for the TMB surcharge for power factor, especially for the large energy consumer. So below than 0.85 and up to 0.75. So within this value, okay, supplementary charge will be imposed for about 1.5% of the bill for that month for each 0.01 unit below than 0.85 to 0.75 lagging power factor will be added to the bill for the month. Okay, so that is 0.01 multiply with surcharge RM something will be imposed if the consumer draw the power factor below than 0.85 to 0.75. And the other condition plus if the power factor is below than 0.75. So this one is the condition one. Let's say the power factor draw by manufacturing A is around 0.5. So both of the condition will be imposed to this kind of value for the manufacturing A. And below than 0.75, in addition to the additional charge payable under one above, okay, a supplementary charge for approximately 3%. So two times from the clause number one, okay, 3% charge. So which means for every single 0.01 unit below than 0.7. So this all those thing will be added in the monthly bill. Let us see the examples of large power consumer called Fujitsu ni Fujitsu ke Fujitsu, okay, bukan nama sebenar not a real name. Okay, has a monthly power factor 0.6 lagging, and its monthly consumption of electricity is 4,800,000 ringgit. So what will be the monthly power factor penalty? How to calculate? Okay, so we know that the power factor 0.6 lagging and not meet the standard set by ST or TMB. So for this one, 10 units, 0.01, right? 10 units of the 0.01 from this one. So 0.85 minus 0.75. So for clause number one, of course, 10 units multiply with 1.5%. So equal to 15%. And for the clause number two, between 0.75 to 0.6. This one is the power factor reading for this Fujitsu. Okay, so 3% will be imposed. That one is the calculation. 3% multiply with 15 units of 0.01. Okay, 0.01 for 15 units lagging. And we know that the percentage of that is 45%. So total up all the percentage is approximately 60%. The penalty charge will based on the 60% multiply with the total cost of electricity, the energy maximum demand, its monthly consumption, electricity bill is the total electricity bill. So the power factor charge is near to 3 million. Oh, see, very expensive charge by TMB. If you draw a lower power factor, you can be charged every month, every single month for about 3 million, close to the total electricity. But okay, so include a main component of electricity bill plus extra one, the other charge. This one is the power factor charge. So the total bill for this Fujitsu is 7,680,000 ringgit Malaysia. Can you imagine? If the power factor is lower than the standard one. So how to do? To do the to do the power factor correction. Okay, power factor correction. You can put a capacitor bank. Okay, and also to have the energy audit first, to identify what's the load that contribute to lower down the power factor. And also especially for the solar installation, okay, if you put kind of the solar, the RE installation, of course, we reduce the power consumption, in the power consumption. But with the unmanner or inappropriate installation for the spec, it will lower down the power factor as well. So when the reactive power will be the measure for to draw and it will contribute to let the power factor to be down, okay, the value. So as mentioned by the TMB, you will be charged for the load factor. So if you are a solar designer, please be in mind that you need um, to have or to be you as the building owner or the engineer for the buildings. So your boss asks you to study about the PV installation. Okay, please also focus on what the load that you can maintain and during the installation and the operation after the installation of the solar PV on a rooftop, for example. So you need to have some kind of the consideration for the power factor. If the power factor is lower, then back to the load and try to get what's kind of the load that contribute to lower down the load factor and try to mitigate, try to solve that kind of the problem by identifying the load involved, especially during the pandemic, when the operation not running well, and some of the capacitive load not also run in that operation, and most likely the RE running to generate the electricity without any kind of the load balancing inside the building, and you can have the result, the power factor reduction, power factor value reduction as well. So that one from my experience, my own experience. So during the pandemic, for the most building that install a large solar generation, for example, they face the same problem for the power factor charged by TMB. So let's do the example on how we can install the capacitor bank. Okay, what's the sizing of the capacitor bank that appropriate to improve the load factor. So now the load factor for this factory is 65% or 0.5. Okay. So the apparent power S is 3 K, okay, the power factor. So we need to have the Q1, K bar. And this one we will also if the okay at power factor, calculate the K bar of the capacitor bank that must be installed at the service entrance, bring the overall power factor. So bring to the unity in order to improve to the unity, and also to bring to the 0 point, sorry, again. Okay. Dia jadi stuck. Nampak tak slide? Okay. So let's, as usual. So this one is the last task for you to submit for today. Okay. You can see these examples. Okay. But let's do some cases. Case one, this one, case A. Okay. The factory have 1000 kVA with 50%. So to achieve 90%. Okay. I hope you can see my slide here. So try to solve this case A, okay, by referring to the examples that has been given in the slide presentation. You can see the flow on how to answer this question. Okay, so if you can get it back to me before 6 p.m. as usual. Can?
Doctor.
Okay, good. So by that way, I think that's all for today. That's all for today. So please get it back to me, your answer. Calculate this case A. Okay, try to answer this case A and submit to the WhatsApp group. Any question before we end off our class for today? Dah ni snap lah. Snap dulu. All right. If there is no question, that's all for today. See you next week. If there is any opportunity for us to do the face-to-face class, I will let you know. Okay, next week. All right. See you there. See you around. Please take care. Assalamualaikum warahmatullahi wabarakatuh. See you next week. Okay. Welcome. Make sure you submit, case A though. All right. Thank you for joining the class. Take care.